Okay, let's look at the theory of magnets and magnetic fields. First, consider a bar magnet, a rectangular magnet with two poles, north and south. The lines of force, they come out from the North Pole and go inside the South Pole, okay? So these are invisible lines of force, magnetic force, which come out of the North Pole and go inside the South Pole, outside the bar magnet. But inside the bar magnet, they move from south to the North Pole. Okay, so just take care of the directions. Outside the bar magnet, they go from north to the south, and inside the bar magnet, they go from south to the north. Now consider two bar magnets, north and south pole, and the second bar magnet in such a way that the two south poles are facing each other. Now when this happens, the magnets tend to move away from each other. Like poles move away from each other. Now if I flip one of the magnets, so I have the North Pole facing the South Pole. In this case, the two magnets will move close to each other. They'll attract each other. Okay, so opposite poles attract each other. Consider a big bar magnet with north and south poles on the ends. And if I cut this bar magnet in the middle, will I be able to separate the two poles? Let's see. So this is my North Pole and South Pole. Now what happens is two new poles are created here, South and North. So every North Pole is accompanied by a South Pole, and South Pole is accompanied by a new North Pole. So it is not possible to separate the poles. Okay, so same thing, if there is a crack in a test piece, there will always be two new poles created at the crack. Let's see how that happens. Consider a test piece. This is the test piece you are going to inspect with magnetic particle testing. Okay, now it is magnetized before you inspect it, so it has two poles, north and south. And in the middle, the magnetic field flows from the south to the North Pole. Okay, now consider there is a crack at the center, which is not visible to the naked eye. But since it's there, there's an air gap, so the magnetic force has to jump outside the crack, over the crack, right? And as we saw earlier, two new poles will be created at the crack, north on the south side and south on the north side. As a result, two opposite poles will attract each other, and also the ion particles that are sprayed in magnetic particle testing. And as a result, wherever there is indication, you'll see accumulation of particles. Let's look at a practical demonstration. Okay, so this is a magnetic yoke, and when I flip the switch on, it generates two poles, north and south. Okay, now as I place it on the test piece, I have two poles on the test block, north and south, and the field lines will move from North Pole to the South Pole. As I spray the ion powder particles, if there's a crack, there should be magnetic flux leakage, as we saw, the jumping over of the force lines, and then the two new poles will be created and there will be particles attracted at the crack. And that's how you detect discontinuities in magnetic particle testing using yoke technique.